The ocean temperatures reached a new all-time high in March 2024, with an average of 68 degrees Celsius recorded on the surface waters. This rise in temperature, associated with the El Niño phenomenon and other climate variations, poses a growing challenge to marine ecosystems. The phenomenon primarily jeopardizes the survival of coral reefs, including iconic sites like the Great Barrier Reef in Australia. Earth Echoes delves into these true maritime cities to expose the gradual and silent death of the ocean's tropical forests. The question is, will we be able to save the corals in time? The ocean surfaces have recorded unprecedented heat over the past 12 months, with daily global temperature records since 2023. This finding comes from a study by the National Oceanic and Atmospheric Administration and the University of Maine, released in March of this year. Global average ocean temperatures have risen by 32.45 degrees, equivalent to about 2 decades of warming in a single year. While ocean temperatures set new records each year, corals are facing a true fight for survival. The U.S. agency NOAA estimates that between 30 to 50% of coral reefs worldwide have already been lost. Without significant long-term changes, scientists believe reefs could completely disappear by the end of this century. It is precisely the rise in sea temperatures that is leading to the gradual death of corals through bleaching. Bleaching occurs when corals lose their symbiotic algae due to thermal stress, leading to reef discoloration. With prolonged heat exposure, bleaching worsens and spreads, leading to the progressive death of corals. Although reversible, researchers assert that the current scenario is alarming. This is because this is the 4th significant episode of coral reef bleaching since 1985. Since then, thousands of reefs have been lost forever, with no possibility of marine life recovery. From then on, thousands of reefs have been lost forever, with no possibility of marine life recovery. Coral reefs, also known as the rainforests of the sea, are essential for marine biodiversity. They provide habitat, shelter, and feeding areas for about 65% of fish species, as well as countless other marine species. In addition to their biological richness, reef areas also offer a range of vital services to humanity. They form the basis of important industries such as fishing and tourism, which support numerous local and global economies. Acting as natural barriers, they protect coastlines from erosion and the impacts of storms and tsunamis. This function is also crucial for the safety of millions of people living in vulnerable coastal areas. Furthermore, organisms inhabiting reefs have unique characteristics that are widely explored by the pharmaceutical industry. New medicines and biotechnological products are created every day using reefs as raw materials for treatments of heart disease and cancer. This highlights the importance of protecting and expanding the extent of reefs, not only for marine life, but also for the health and economy of the planet. The rise in ocean temperatures is one of the most alarming symptoms of global warming reality. The subsequent climate changes are systematic signs of a complex and high-risk imbalance for the balance and maintenance of life on Earth. At the heart of this problem is the increase in greenhouse gas emissions, mainly released by the burning of fossil fuels and deforestation. These gases act like a thermal blanket around the planet, trapping the sun's heat on the Earth's surface and consequently raising global temperatures. Additionally, the El Niño phenomenon, a natural climate oscillation that occurs in the equatorial Pacific, plays a compounding role in warming. While it is a periodic event, climate change can intensify its effects, resulting in hotter and longer periods than usual. Other factors, such as reduced marine pollution and decreased winds in the Atlantic, also contribute to successive temperature increases. Humans are now beginning to feel the danger of this warming firsthand, with annual heat wave records in various parts of the world. In the oceans, the combination of all these elements can cause changes in ocean currents, thermal circulation of waters, and ocean pH. All these aggravating factors lead to loss of biodiversity, with changes in migratory and reproductive patterns of marine life. The melting of polar ice caps and rising sea levels are visible, with scientists warning of advancing waters over coastal areas. Case studies on coral bleaching provide a critical and detailed insight into the devastating effects of ocean warming. The Great Barrier Reef in Australia and the Costa dos Corais Environmental Protection Area in Brazil are among the key sites impacted by coral bleaching. In Australia, bleaching events have become more frequent and intense over the years. As a result, the largest coral reef in the world has been reporting alarming episodes that compromise its resilience and recovery time. Satellite images and other remote monitoring technologies have been crucial in assessing the extent of damage and planning conservation actions. Brazil has faced similar challenges. Scientists have documented a significant reduction in live coral coverage, with an average decline of 18%. This area suffers from high coral mortality rates and marine life that directly depends on reefs, reaching 100% in certain cases. When corals undergo this excessive thermal stress, they expel the so-called zooxanthellae, the algae responsible for vibrant coloring. The expulsion of these algae results in the gradual loss of this coral palette until they turn white and die permanently. Even small temperature increases, such as 33.8 degrees, can drastically disrupt the symbiosis between corals and zooxanthellae. Addressing coral bleaching requires a combined approach of mitigation, restoration, and technological innovation. Reducing greenhouse gas emissions is decisive to slowing down global warming and its effects on the oceans. International initiatives like the Paris Agreement are indispensable, setting rigorous goals for reduction and transition to renewable energies. Simultaneously, the scientific community emphasizes efforts to restore coral reefs and recover these ecosystems. Techniques such as microfragmentation have proven effective in accelerating coral growth and increasing survival rates. In the field of technology, researchers are developing and applying innovative solutions to combat the effects of heat waves on corals. This includes the use of artificial water cooling systems and the application of special sunscreens that help protect corals from excess sunlight. Predictive models are also used to forecast bleaching events and mobilize rapid and effective responses. However, the effectiveness of these measures depends on their widespread implementation and collaboration across all sectors. Scientists agree that saving coral reefs will not be an easy task, and the primary threat continues to be global warming. Despite efforts to mitigate greenhouse gas emissions, the impacts are already visible and growing. Local factors such as pollution, sedimentation, and overfishing further amplify the vulnerability of reefs and decrease their resilience. The frequency of bleaching events compromises the corals' ability to recover as they struggle to adapt to rapid environmental changes. The protection of marine areas and the implementation of the blue economy emerge in this scenario, promoting a sustainable way of caring for and exploring the oceans. Equally important is the mobilization of society and the demand for public policies to preserve the wealth of marine life. Earth echoes will continue to resonate amidst the vibrant colors of these magnificent environments, home to so much life and biodiversity. If you've ever dived near a coral reef, write your experience in the comments below. Don't forget to like and share this environmental alert. See you in the next dive.